Jai Shri Gurudev. Let us talk about derivation of centroid of a semicircle. Now I am going to consider a semicircle over here, something like this. This is going to be my x axis, this is going to be my y axis. The radius of the semicircle is going to be r. I am going to consider a small elemental strip, something like this. Now let us say that this strip makes an angle of theta with respect to xx, and here let us call this distance to be d theta, and by your sector this arc distance is going to be r into d theta. So once this is done, I can say that the area of this particular triangle, whatever is going to be there, if I'm trying to find out the centroid for that small elemental strip, I can tell that it is going to be concentrated somewhere over here like this. How? In the previous class we talked about a triangle, and then we told that the centroid is going to be present towards the area where it is going to be more, something like this. So here we wrote that this is 1 by 3 of d, and we also wrote that this is 2 by 3 of d. Yes. Now this small elemental strip that you can see over here, this elemental strip, this resembles a triangle. Now this is r, this is r. If you're trying to find out what is this particular distance from this point to the point where the area is going to be concentrated, then based on this, this is going to be 1 by 3 of r, this is going to be 2 by 3 of r. Now once this is done, if at all you're trying to find out what is the distance onto the x axis, now I'm going to drop it onto the x axis. I know that this is theta and then this is d theta. Yes, so it is going to be something like this. This is 2 by 3 of r, and then this is theta. I am trying to drop it onto x axis. Okay, so because I'm trying to drop it onto x axis, by resolution I can write this as 2 by 3 r cos theta. So if I drop it, this distance is 2 by 3 r cos theta. Alright, now let us talk about the area of semicircle first. Area of semicircle is going to be pi r square divided by 2. Now let us consider area of elementary strip. Area of elementary strip, I told you it resembles that of a triangle, so it is going to be half into base into height. So half, I'll just write down the triangle over here again. Okay, height is r d theta, base is r, so half into base into height. Now I have dropped the centroid from the triangle onto x axis. The projection distance is nothing but 2 by 3 r cos theta. So the next thing what I'm going to do is find out the moment of area of the elementary strip about AB. So if I'm trying to find out the moment of area, first it's going to be area of the strip, that is nothing but half into r d theta, or I can write r square d theta into, what is the distance? The perpendicular distance is 2 by 3 r cos theta, or if you multiply 2 and 2 is going to get cancelled, r square into r is r cube into cos theta d theta divided by 3. Now summation of such moments. So sum of moments of such elementary strip. If I calculate, I'm going to do integration over here. So integration, if you can see, this the lowermost point is minus pi by 2, the topmost point is going to be pi by 2. So these are going to be my integral limits. So the lowermost limit is minus pi by 2, uppermost limit is going to be plus pi by 2. R cube divided by 3 cos theta into d theta. We know that r cube by 3 is constant, cos theta d theta, integration of cos is nothing but sin theta, pi by 2 minus pi by 2. Substitute the limits, r cube divided by 3, it is going to be sin of pi by 2 minus of sin minus pi by 2, or this is nothing but r cube divided by 3, sin pi by 2 is nothing but sin 90, 1 minus sin of minus pi by 2 is nothing but sine of minus 90 degree, that is nothing but minus 1. So it is 1 minus of minus 1, so 1 plus 1. This is 2 r cube divided by 3. Call this as equation 1. The next thing is moment of total area about your y-axis. So what is the total area? Semicircle is pi r square divided by 2 into centroid. Let us just call it as x bar. Call this as equation 2. As per your principle of moments or your Varignan theory of moments, 1 and 2 are going to be equated. Pi by 2 r square into x bar is equal to 2 r cube divided by 3. R square gets cancelled. I can write x bar is equal to 2 and 2 gets multiplied. So 4 r divided by 3 pi. This is the centroid of your semicircle.